I've worked, I think I'm the main developer on Ring. I author Clojure and Hiccup, Line Ring, and a few other web libraries as well. That's my Twitter, and that's my GitHub address. So I encourage you all to follow me, because then I get more followers, and it looks nice. So, as I said, this is the first talk I've done. If it goes terribly, then you can all blame Bruce, who volunteered me, or voluntold me, as somebody once said. And the only other thing I want to add is that I recently quit my job, so to do Clojure full time. So if anybody wants to, thank you. So if anybody wants to hire me, then, and if the talk goes well, then you're welcome to. And if it doesn't go well, then forget I said that and use the next talk as the baseline. Okay, so Ring, what is it? Well, it's an abstraction over HTTP. And logical question after that is, well, what's HTTP? And I guess most of you know that it's a protocol the web is based on. But more importantly, for our purposes, we care that it's a request-response protocol. And that means that we send a request to a server, and only when the request has finished do we get a response. So it's not a channel which you can, the client sends some data and they get some data back, and then the client sends some more data and they get some more data back. It's very sequential. So the server will not start sending a response until the request is entirely done, partially because the response has the error code as its first element, and if the request hasn't finished, it doesn't know whether the request causes an error or not. So if we're going to abstract this in Clojure, then we need a way of representing this in Clojure. So we need a way of representing some sequential operation which takes in a value and then returns another value. And in Clojure, that kind of abstraction, or the tool we have to do that, is actually just a function. So if we're going to abstract this into Clojure, if we're going to represent this in Clojure somehow, then we'd have a function, in this case it's called server, and it takes a value in, which is a request, and it returns a response. And usefully, HTTP and Clojure share certain properties. So in HTTP, once you've sent the request, you can't do anything to it. It's a value. It's immutable. So if you send a request, you can't go, actually, I want to change that. Don't send me the response anymore. I want to do over what I did. Once you've sent a request, that's it. And once you've sent a value to a function in Clojure, that's it as well. You can't modify that value. All values in Clojure are immutable. So these are two properties which they share. So it actually maps quite well. A function is almost exactly what HTTP is doing. And I mean a function is in something that takes an immutable value and returns an immutable response. So we could just use this, and we could just call it a server, but it would be a bit confusing if we used the term for our abstraction as the term for the actual concrete implementation. So we want to call the concrete implementation a server, and the abstraction in Ring we call a handler. So handler is the abstraction, and server is the actual concrete thing that it produces. So we have a handler, and it's just a function. And, well, so we've answered one question, which is how do we abstract a server in Clojure? The next question is, how do we abstract the request and the response? So a HTTP request looks like this, and maybe some of you have seen this before. Certainly if you're on web development, you probably have done. And this has certain properties. So the first bit is the HTTP method. The next bit is the URI, the actual location of the resource we want to get. And then we have a bunch of headers. In this case, because it's a GET request, we don't have a body, but with POST requests, we do. And you can pretty much ignore the HTTP 1.1 because all HTTP requests are 1.1 nowadays, and that will only change once Google and other companies start introducing new things like Speedy. But for our purposes, we just focus on HTTP 1.1, so we don't really care so much about the version. And the question is, how do we represent this in Clojure? So we've got a bunch of values, and they're named values. So they actually have some kind of identity. So the way we represent named values in Clojure is, well, a map. So in Ring, this is what the previous request looks like. The method becomes a request method, and we use a keyword. And we've got the URI, and we've got the headers, and the headers themselves are a map, so it's a map within a map. And maybe this isn't so surprising, maybe it's quite sort of obvious that you represent it in this way, and that's good. So abstractions should be obvious. If they weren't, then there's maybe something wrong. So next we have HTTP response, and like a HTTP request, we have certain values which mean certain things, and this time we've got a body. We haven't got a method, we've got the status, and we've got a bunch of headers. And it's probably not too surprising to learn that actually we can represent this as a response map as well. So again, we've got the status, 200, we've got the headers there, and we've got the body, which we represent as a string. So in Ring, we have this abstraction where we have a map, which represents the request. We pass it to a function, and we get back a map representing the response. And this is the only abstraction in Ring. That's it. There is absolutely nothing else in Ring that's an abstraction. Everything else is libraries and leveraging this abstraction. And this is good, because few powerful abstractions are better than many weak abstractions. It's easier to learn, and if you just have one abstraction, you can leverage it in multiple different places. So we have an actual concrete implementation, which is HTTP server. We have a request, goes to the server, we get a response, and we have our abstraction of that. So in Ring, in Clojure, we represent that as a map going to a function returning a map. And we need some way of bridging the gap, because otherwise we're not really doing anything. It's kind of useless if you've got no way of turning what we have in Ring into actually a proper web server. And the gap is bridged by something that in Ring we call an adapter. So we're saying we're adapting this abstraction into something concrete. So let's actually see an example of this. So maybe this is all a bit sort of abstract, and we actually need to ground this in something. So here's an example of a handler, and you can see it's a function that takes a request. It doesn't actually do anything with the request. It just returns hello world each time. So a status of 200, which means which is a status code, which means OK. We have headers saying that this is a content type with this is just text, and we have the body, which is just a slice of text. And this is fine. This actually represents a handler, but we can represent the handler a little more concisely using a library. So Ring comes with a lot of namespaces in its core system, and one of those is Ring util response. And these give you functions to create and manipulate responses. So the first function there, which is called response, creates a 200 OK response with just the value inside it. And the next function, the content type, modifies the response and actually sets the content type. So you can use the threading operator there to chain things, to modify a response and create it incrementally. And this is maybe a little bit clearer than the previous version. We've lost a line, so that's good. And maybe it's a little bit easier to read. I mean, that's a bit subjective, but I kind of think that a text response kind of looks like this. So now we've got this abstraction. We want to actually turn this into a web server somehow. We want to actually use it in some way. And we can do that by adding this adapter. So in this case, we're taking the default adapter, which is based on the Jetty web server. And this is bundled in Ring, so you don't have to write an adapter yourself. And the adapter is just called run Jetty. So we give it the handler, and we give it a set of options. And in this case, I'm just telling it the port. I think by default it tries to run on port 80, and usually you don't want that because port 80 is only accessible by root. So if you want to run the web server on a non-privileged port, then you give it a port. In this case, we're just saying 3000. So that's how the system works. I mean, that's a fully functioning program. You can take this code and you can put it into a file and you can run it. And assuming you've got all the right files in your class path, or if you're running it via Leiningen, then this will work. This will create a web server, and then when you try and access the web server on localhost 3000, it will return hello world every time. But why abstract at all? I mean, we have this abstraction, but why not just use Java servlets? Or why not just write directly to the TCP stream? Why do we actually want to do this? Because we're not just going from TCP, we're also Ring leverages Java servlets as well. So we're going from TCP to Java servlets, and on top of that, we've got Ring itself. So you've got sort of multiple layers of abstractions, and you kind of think, well, why should we do that? Why don't we just work with Java servlets? Because they're more, there's lots of technology based on Java servlets. Why don't we just use them? And this was one of my arguments to Mark, who was the creator of Ring, first of all, several years ago. And it took me a while to realize that he was right and I was wrong. And the answer really is power. Or more specifically, the power to leverage Clojure. So if we abstract this behavior into Clojure data structures, then we get all of the power of Clojure to actually do things with it. So we can manipulate maps using, we can manipulate the request and response. If they're maps, then we can manipulate them with a sock and other functions. We can use all of the tools the language gives us to do this. So we don't need to create a function to change the request in some way, because there's a there's a Clojure function that will do it for us. So by abstracting this, we get the whole power of the language, and we don't have to write so much ourselves. We don't need to write functions to change headers or anything like that, because changing headers is just changing a value in a map. And one of the ways this power manifests itself is in something that we call middleware. So middleware is not a new abstraction. It's just higher order functions. And higher order functions are functions that return functions, or functions that manipulate functions. If you use a language with lambdas or something, you may be familiar with them. So JavaScript sometimes uses these, and Clojure obviously uses them a lot. So if a handler is transforming a map into another map, so transforming a request into a response, then middleware is transforming a handler into another handler by giving it some additional functionality. So it's almost one level up. So you've got a handler, which is a map to a map, and you've got middleware, which is a handler to a handler. So it's kind of like one layer above, sort of one dimension above the previous, and that gives you more power. So if we have our original request, handler, we have our request going into handler, and it returns a response. Then we can wrap that in a middleware function, and this effectively wraps the input going into the handler and the response going out of the handler. And because it wraps these things, we can alter anything which falls inside the middleware. So anything which falls inside the domain of the middleware, we can manipulate in some way. So here we can manipulate the request going in. It's a little bit difficult to see on there, but there are red circles around the request line, the handler, and the response. So we can manipulate the request before it goes into the handler. We can add something to the request. We can choose whether or not to actually run the handler at all. And we can also manipulate the response. So how does it exactly look in practice? Because, again, it's theoretical. I like to kind of ground ourselves in some code. So this is like the identity middleware. And here it's just wrap identity. We're kind of stealing the identity function. Really does pretty much the identity function. We pass in a handler. And then we return an anonymous function. So we return a sort of new handler, and this just wraps the old handler. So this doesn't actually do anything, because that function that it returns just returns the original handler. So this is the identity function, just a piece of middleware which does nothing. But it's useful to know because all middleware kind of falls into this pattern. You define a function which takes a handler and maybe some arguments, and then you return another function which looks like a handler. So you can use handlers for sort of various things. One of these things is caching. So in this case, this is a slightly more complex piece of middleware. If we can, so first of all, we try and match the request against the cache. So we send the request to the cache and say, has this request come in before? Can we actually return a cache response instead of working it out ourselves? And if we can't, if that returns nil, then we actually need to generate the response by going to the handler, saving the response inside the cache, and then we just return the response. So just by adding this middleware, suddenly we get caching. And this might seem a little sort of familiar if you think about HTTP proxies. So usually if we talk about HTTP caching, we're talking about a HTTP proxy which sits in front of your web server and caches things. And a HTTP proxy is very similar to middleware. They kind of fall, they have similar jobs. So this is another type of middleware. I realize that this code might be a little bit dense. It's perhaps the weakest part of the presentation. But bear with me and it'll get slightly easier. So in this case, we're adding a content type to the response. And this is effectively some middleware which is already in Ring. So in this case, we're getting the extension of the URI. So it's .text or .html, we'll be getting that thing. And then we will be matching that against a extension type of some case. So we'll be taking .text and we'll match that against text.plain. We'll be taking HTML and we'll be matching it against text/HTML. And then we use the content type, we just add it to the response. So you can see we're reusing that content type function we mentioned earlier to change the response. So this is adding a valid content type based on the extension, the file extension we're getting. And then finally, just some middleware which parses the parameters of a request. So this is probably important to know. Ring, if you remember, if you think back to the request we showed, the request didn't have things like parameters or cookies inside it. It just had headers, request method, URI. So Ring doesn't try and abstract things like cookies because you can just take the cookie out of the header. So a cookie is like something on top of HTTP. If you go through the HTTP spec, it doesn't really say anything about cookies. That's a separate spec. Cookies are built on top of HTTP. So parameters are as well. So this is URL encoded parameters. In Ring, you just get the query string. So you just get the unencoded query string without any parameters inside it. And then Ring has something to actually parse these. And the useful part of this is that because this is in Ring's standard library, the people creating adapters don't have to recreate this stuff. So if you're creating an adapter, you just need to create something which parses a HTTP request. You don't need to worry about sessions, you don't need to worry about cookies, you don't need to worry about parameters, file handling, or anything like that, because that's all handled by Ring. So in Ring core middleware, we have some middleware for parsing query and form parameters, so you don't need to worry about that. Multi-part file uploads, so it'll handle file uploads for you. Cookies, sessions, setting the content type automatically, and also serving any static resources you have, like images or CSS files. So the Ring core middleware, there's quite a lot there, and it's quite a lot of useful stuff, and a lot of stuff you use in sort of every application. Maybe not in an API, so you can pick and choose a little bit. In a website, you probably want file uploads, and you'd want sessions. in an API, you probably wouldn't. So all this kind of gives you the tools to create a functional website with just one page. So we haven't talked about how we get multiple resources. So how can we return multiple pages? How do we return multiple resources from the same handler? Because at the moment, we've just seen hello world, which is fine if you just want your web server to return one thing, but not so fine if you want a website with multiple pages everywhere. Yeah, different pages. Yeah, so not just hello world, but if you go to a different page, then it'll return something different, and so on and so forth. So you could just do it something like this. So you could just have a handler, and that just has a case statement on the URI, and you could just say, okay, well, if it's /hello, return a response with hello in it. If it's /world, return a world response. Otherwise, just return a not found page. And not found is a function which is part of ring util response, because quite often you want a not found response. So you could do it this way, but if you do it this way, then it starts to get more complicated as your site gets more complicated. This is okay for like 3 routes, but then when you try and get routes that have identifiers in them, which have UUIDs in them, suddenly it becomes very difficult. And this case statement would explode into complexity. You have to put in if statements and regular expressions and all of this sort of stuff. So it'd get complicated pretty easily, pretty quickly. So that's where Clojure comes in. So Clojure is a routing library, and Clojure actually predates Ring. So we actually started writing Clojure before we started writing Ring, and this was when I was convinced that Java servlets were the answer, and I was quickly put right on that course. So Clojure code looks a little bit like this. We have here a root, and it's a lot nicer than the case statement we were seeing before. It's also a lot, it's not as obvious, but we're packing more information into a single line. You may sort of say, well, what does that actually mean? I mean, clearly we've got a get statement and we've got /hello, so maybe we're handling this somehow, and we've got this request here, so maybe that's like the request which is being passed in, and hello, what does that mean? Does it mean something? I don't know. So this expands out. This is actually a macro, which expands out to a function like this. And this function does 2 things. It returns the content, which is there, so it's the hello. So it actually returns the value being returned. It returns the content you want to send to the user. But it also tests whether or not this is the right route for the request. So it tests to see whether or not the request method is equal to get, and it tests to see whether the URI is equal to /hello in this case. So it combines both functions. It combines both returning the actual data and checking to see whether it should return the data. And if it shouldn't return the data, it returns nil. So this is the get. You can see it relates to the first part there, the macro name. Second part, the URI, relates to the second argument there. The request is the bindings. So it's how you bind the request to some symbol which you can then use later. And hello is the content you return. So this is one route, and it wouldn't be very useful on its own. We clearly want to use it with other routes, and you can. And there's a function called routes which will combine routes together. In this case, I'm using underscore instead of request. If you're familiar with Clojure, then you'll know that underscore is like an argument we don't care about. So that's all it means. It's just an argument, but we don't care about it, so we're just going to throw it away. And routes can, because this pattern, this where you define a handler and then you use routes inside it, because that's a very common pattern, we have a shortcut called def routes. And that just means the same thing. It's literally just def routes. It's not doing very much. It's just collapsing that into that. So this works by cascading. It first checks the first route, and then if that returns nil, it goes to the next. So if the first route matches, that's fine. It gets a request, it gets back a response, and then that's okay. But if the first response says no, actually the request doesn't match, then it goes on to the next response. It goes to the next one in the sequence. And maybe this request, maybe this route will actually match, and it'll return a correct response. And if none of them match, well, it just returns nil. It effectively just falls off the edge. And usually in an application, we don't want it to fall off the edge, because then we get null pointer exceptions when we pass it to our website. So we want something to catch the end nil. We never want to return nil, because a web server doesn't know what nil is. A web server always expects to return a response. So in our case, we usually have a not found route. And Clojure provides one of these as standard in the root namespace. And this root not found is just a function almost exactly like the hello world function we had before. And it just returns the exact same response every single time. The only difference is that our hello world program responded with a 200 OK response. This will return a 404 not found response. And in this case, we can see that the request goes through, and even if it's all nil, even if nothing matches, the root not found response is guaranteed to always match. So if we go back to this, to our code, we have our hello world and we have our world. So we've got 2 pages here, and each page returns a single value. But this is a little bit inefficient, because we've got hello, hello, and world, and clearly we're programmers. We want some way of making this a little bit easier. So wouldn't it be nice if we could take the value from the URI there, from the path, and use it in our output? So we can, by taking the request, because we've got the request, we can look into the request and say, okay, we'll take the look into the parameters map, and then look for a parameter called word. And if you've used Rails or something like that, you might be familiar with this syntax, where instead of having a static root to match, we've put a little colon on the front, and that signifies a variable. And this variable is accessible through the parameters map. But this is a little bit wordy. If we had to do this every single time, it would quickly get boring. So we could use destructuring, which is a feature of Clojure. And this allows us to, instead of binding to a single parameter, to actually reach inside that parameter and bind to something else. So in this case, we're saying, okay, well, don't bind to the request as a whole, look in the parameters map, and then look for word in the parameter, and then bind word to that. But again, this is a little bit wordy. It's quite big. If we want to do this every single time, it'd be quite boring. So Clojure gives you a third option. It says, well, if you use a vector as your bindings, then we will just match on the parameters. So what it says is, okay, we expect a parameter called word, and we're just going to return word. So what happens if we want to have another route? And maybe we want to shout a word as well as actually having just a word which returns, just a route that returns the word. And in this case, this word shout route, we're returning the uppercased word. So if I typed in /hello, it would return hello. If I tried to get hello/shout, it would return hello in capital letters. But this is these 2 routes. There's some duplication still going on. So both these routes have word at the beginning, and really we'd want to factor out that prefix, because that prefix is common, and the context macro does that. So as well as macros like get and post and put, we also have this context macro which allows us to factor out a prefix, a common prefix. In this case, the common prefix is word. So we factor out this word because we know it's used in both routes. And then we can just say, well, / is like the sort of root. And then we use shout. So this gets transformed into this. And in this case, it's not hugely useful, but in other cases, if you have a lot of things which use the same prefix, it can be quite useful. So Clojure has macros to create handlers. So things like get, post, put, patch, delete. All of the HTTP methods you might want to use are macros in composure.core. You can also cascade handlers, so you can join them together. You can make it so that you first check one handler, and then the next, and then the next. So you can combine routes together. And you can also nest routes. So you can nest handlers using context. If you have a common prefix, you can nest a whole bunch of stuff inside. And so this all looks like, well, this is a functionality which is found more or less in any other website or web framework you might want to use. I mean, maybe context is a bit unusual. Maybe that's a bit fancy. But just doing routes is actually pretty standard. You don't get a web framework where you can't reply to multiple pages, where you can't define these routes. So what makes Composure special? I mean, why is it? Why am I doing this, and why am I not doing Ruby on Rails or Django or anything like that? Well, because these are functions, we can do things like selectively apply middleware. So this is a bit of a more realistic example. Here we have this authorized middleware. So maybe this middleware makes sure that only users who have access to their page can access it. And if it detects that a user doesn't have access, it returns a 403 unauthorized response. So you can have this middleware return the page if the user is allowed to go to the page, or it can return an invalid response if it's not allowed. And then we've got a context where we get the UUID, and we can use a let value inside this. So we can actually get the user. So we don't have to just refer to the user ID. We can actually put a value in for the user. And then we can specify these routes down here. And suddenly it looks kind of quite neat. We're kind of nesting things. And we're nesting things in a very concise way. So in something like Ruby on Rails or something, you'd have to build big classes for this. We can do this pretty concisely. And I think concise is better. If you think about all the times in Java you use anonymous objects, you don't use them that much. But in Clojure, you use functions a lot, even though they're kind of equivalent. And you use them much more because the syntax is much more concise. So concise syntax, I think, really matters, especially if we're going to be doing this a lot. But more importantly, we can actually factor something out. So what we can do is we can factor out those routes we saw here. So these routes down at the bottom, we can factor those out into a separate function. And this function takes a model, like a generic model. And this model might implement a set protocol which gives it access as a getter, a put, and delete. And so long as this model implements a protocol with these methods in it, then we can use this REST routes for anything. So in this case, we're using it for a user, but we could use it for a post or a comment or anything which we want to put, a delete, and a get. So we go back to the original. This is how it originally was, and this is how the routes are factored out. And really, we haven't actually, this is the same amount of lines of code. We factored these routes out in something very generic, and it's still the same lines of code. We've lost the let, and we've got a new defined function up here. But actually factoring this behavior out into a separate function is really, really easy. It requires very little effort. And I think this is one of the things that makes Clojure and Composure in particular pretty unique. Because I haven't seen in any other web framework this ability to factor out a generic set of routes into a function in this case, or in Ruby or in Python it would be an object, but so easily, without really using any more lines of code. So I'm nearing the end here. So what's the big idea? And I've kind of touched on this. The big idea of Composure is that complex handlers can be a composition of smaller handlers. So you can think of it as an orchestra. In an orchestra, you have many individual instruments, which sometimes they do quite complex stuff, but they combine into a whole which is so much better than the individual tunes that they play. And you may have guessed that that's where the sort of word composure comes from. That, and because I was annoyed with all other frameworks, so I wanted something which would keep my composure. And this fits in quite well with Clojure as a whole. It's very idiomatic, because Clojure is naturally about taking small functions which do very specific things and combining them into a greater whole. And this also links into service-oriented architecture. So I think Amazon probably pioneered it, where instead of building a great big web service which does everything, in Amazon they create small little web services which talk to other small little web services, and their whole infrastructure is made up of thousands of these little web services. And really that's what we're doing here, but with functions instead. In Composure, every handler every function tends to return a handler. It's a library for creating and manipulating handlers. So you could say that it's effectively function-oriented architecture. It's very similar to service-oriented architecture. And because it's very similar, you can easily convert from one to another. If you want to factor out a particular function into another web service, you can, because they're all just handlers. So just one more slide. So I just want to talk about, very briefly, what's next. So this is what we've got so far. But there's still a lot to do, and there's still a lot I want to investigate. Things like content negotiation, I'd like to have something like that, so we don't need to do so much with web services. RESTful abstractions, finite state machines, can we somehow combine this idea with a finite state machine? And maybe Clojure script integration, so can we have a system which automatically integrates with Clojure script, a bit like Backbone.js implements with Node.js. And that's the end. So there we go. So are there any questions? Yes?
So you talked about this decomposition of things into small things, functions to functions. Sounds correct?
Yes.
One, and you compared to Rails.
So the question was, making things out of small functions is all very well, but you need a skeleton, or it would be nice to have a skeleton of where to put things in, if that's an accurate representation of the question. Yeah, or do you need a skeleton to actually put these things? So there's frameworks like Noir, which try to give you a sort of simple framework. There's nothing which goes the whole MVC route in Clojure with compared to Rails. The idea of providing a skeleton is, I think, a good one to sort of get going, but as time goes on, you tend to be constrained by that skeleton. I mean, maybe this is a talk for another day, my kind of problems with Rails, so maybe I'll save that for a future talk. But yeah, I have some issues with the MVC model. Yeah.
I'm just talking about if you've got a very complex site,
yeah.
Lots of small
I think the kind of solution is to not have a big site, to factor things out into very small things, in the same way that in a service-oriented architecture, you'd factor things out into individual services. It might be easier to use Rails, so Rails might be the easier framework to get started with, but I think Clojure and Ring are maybe the simpler framework. So they emphasize simplicity, not having very few interconnecting pieces, whereas Rails tend to implement the easy. I think. Oh yes. Paul was saying that Rails community has sort of been working the other way. They've been trying to pull apart the monolithic framework they have at the moment. So they're effectively trying to work backwards to making things more simpler by pulling out active model into its own thing, active resource into its own thing, and we're effectively coming from the other direction with Ring. So we're starting from something which is very simple and very spread out into separate components which do very simple things, and we're working towards easy. So we're kind of two groups, but we're working towards the same sort of intermediate goal. We're just working from two different directions. I think we've kind of got an advantage. I think it's easier to go from a simple thing to something which is easy than to go from a complex thing to something that, or to a complex and easy thing and go to something where it's a little simpler. I think it's easier to make something easier than it is to make something simpler. Yeah? Is there any support for laziness? Yes, there is. So I showed bodies which were just raw strings, but you can also supply input streams, and you can supply lazy seeks as well. So Clojure has a concept of sequences which are lazily realized, and you can provide one of those as the body instead. So you could have an infinite sequence, or a sequence of like 1 million records realized, and it would come out one bit at a time. So I didn't reach that abstraction. Mark did. Oh yes, sorry. So the question was, how long did it take us to reach this abstraction? And were there any ideas tossed away along the way? And the answer is, I don't know, because when I got this, Mark had already developed it. So he developed the first abstractions you saw. The very first abstraction that I covered in the first dozen slides or so, that was already there when I ran across Ring. And everything over that, then I would kind of implement in the middleware and everything beyond that. So you need to ask him, I think. But I think he based it pretty closely on RAC, and RAC was based on CGI. So there's kind of a history going back, and I think with each iteration, it's a little bit better. So with RAC, it's very difficult to actually manipulate headers, because headers are passed as environment variables, which is kind of crap. Whilst in Ring, we pass them as a map along with the request object. So I think it's more like an incremental thing. Each Ring is sort of inspired by RAC, and it sort of fixes some of the problems RAC had, and RAC was inspired by CGI and fixes some of the problems that CGI had. Oh, doesn't it? Oh, okay. I stand corrected then. I'll go with Bruce. So the question is, who, if anybody, is working on these problems here? So I'd like to take a crack at some of them, but people are welcome to do so. I don't know that there's any formal sort of organization of you must do this and you do this. So this is more of a wish list rather than a battle plan. Pardon? So, yeah, I was going to look into that, but I haven't looked into that yet. That was just one of the things I thought of in Starbucks this afternoon, and I decided to put it in. So I believe there are some stuff in Noir which with some Clojure script integration, but I don't believe there's any generic middleware which fills that gap. Yes, that's Oliver, I believe. The question is there a project in GitHub which is good for learning this stuff and which does all of this stuff already? The answer to that is that I don't know. There might be one. I'll look on the mailing list, and if there are, I might add them to the Composure or Ring wikis. I've also been meaning to write some example projects just to compare the MVC approach with a more kind of functional approach. Yes, you can. So you're saying that can you apply middleware inside a get macro? You can effectively apply the middleware at any point. It just depends on how much you're wrapping. So if you kind of put it at the top, the middleware will apply to everything. If you sort of focus it down and just apply it to a single handler, then it'll just apply to that single handler. But it's all handlers all the way down, so you can apply the middleware at any point. Ian. So is it possible to... Sorry, I don't really understand. Yeah. Yeah, I think that's more... So the question is, can you kick off ring handlers in other JVMs from one JVM? So I kind of think that's almost sort of remoting type / sort of transfer problem. Yeah. So you need some way of transferring the handler across to the other servers, or the other servers happen to know about the handler. But then it just becomes a kind of data transfer problem. You could just transfer the jar file which contains your handler to all of these servers, and each server would then run an adapter, which you could then wrap in a proxy server like Nginx or something and serve it that way. So I don't know if that answers your question, but okay. So the value of each header. Oh yes, sorry. I keep forgetting to repeat the question. So the question is, can you have multiple headers if you just got a map? And the answer is you can if you supply a sequence as the value. You'd have to ask, so is there a deliberate design choice to do that? You'd have to ask Mark. But I think most of the time you want to just have single headers. Multiple headers are sort of maybe the exception to the rule. So that's probably why. How are we doing on time? Do you have any? Okay.
Yeah, so you talked about things you want to do and how people can get started. One thing.
No, but I could do. That's probably a good idea. So the question. So I keep forgetting to actually say the question. You can tell I'm new at this because I keep screwing up. But the question is: are there going to be any hack days on Composure and Ring for the community to help out? And I think that's a good idea, but I haven't organised any. Yes. If you want to help, if you want to organise some, then that makes my job easier. So that's good. The question was, how do WebSockets fit into this? And the short answer is they don't. The longer answer is that you have libraries like Aleph which support WebSockets, but WebSockets are effectively so different from HTTP. Well, they are a separate protocol. So I think you need to treat them differently. Aleph works by effectively splitting it up into two. You have a function which turns everything below it into a kind of ring, and then you have a function which turns everything below it into a WebSocket. And you can kind of have the two routes. So you can say, well, this is a WebSocket route, and this is a normal ring route. And then you have all the advantages of Ring and all of the sort of guarantees you have with a HTTP server. So you don't need to worry about things coming in asynchronously. And then the WebSocket routes, you have all the power of WebSockets, but also all of their problems as well. Any more?